Okay, so we're now in a position to state the Noether isomorphism theorem, which is due to ME Noether. And uh, we'll state it, and then we're going to say sort of how we're going to use the theorem. Okay, this is a very, very, very important theorem. I don't know if you star things, if you're the type that stars things, put like a bazillion stars. Do I have a star? Here we go. Star it, you know. This is a very important theorem. So let's state it, and then I'll tell you how we're going to go about using it. So suppose you have a ring homomorphism, then R mod the kernel is isomorphic to the image. Now, that's not surprising at all. We actually proved this, right? So that was the content of all of the previous lemmas. So here's the statement here's the function. Here's it showing it's actually well-defined, which you have to do whenever you have cosets. Here's it showing it's a homomorphism. Here's us showing it's one-to-one. Here's us showing it's onto. Therefore, it's an isomorphism, and we're done. Okay. So that's the first. That's the statement. So there's not going to be any proof because our sequence of lemmas proved it. There's a special case here though. So when phi is already an epimorphism, so that if we happen to come up with a homomorphism that was already onto, we have an isomorphism R mod the kernel is S, right? Because if phi is already onto, the image is already everything. So the image is just S. So there's nothing to prove here. So let me just say proof. It follows from the previous four lemmas. And by follows, I don't mean like you have to think about it. You just write out each of the previous four lemmas. Okay, so there's not any content there. So how are we going to use it? So again, very, very powerful theorem. So how do we use it? Well, one of the ways in which we're going to use it is we've introduced these R mod i's, right? And we did one example of an R mod I, only one. And well, I guess Z mod M is also an example. So we did like two examples of an R mod I. But a question is that you can ask about these R mod i's is what are they? Namely, like, are they familiar? And if they're not familiar, can we sort of like try to understand all of the rings that come from an R mod I? How do we know if we have a redundancy? You know? So the primary way that we're going to try to apply this is we're going to try to understand what is R mod I? Like, can I recognize it as something? And so how does the Noether isomorphism theorem help us answer this question? Well, what we need to do to understand an R mod I is the Noether isomorphism theorem. I'm going to write Noether iso theorem says we can understand, we can, well, let me say in quotes, determine R mod I by finding a surjective, so an epimorphism, let me just use the right language, an epimorphism phi from R to some ring S, such that the kernel of phi is I. If we can do this, then the Noether isomorphism theorem tells us that R mod the kernel, but the kernel is I, is S. So we've sort of correctly identified R mod I as S. Now, what correctly identifies means and why R mod I is not good enough, you know, that we're not going to go down that route. Sometimes R mod I is good enough, but sometimes you'll get some familiar things, and those familiar things are important to recognize. And we're going to do examples of this. But this is how we're going to try to go about using it. So we're going to try to come up with homomorphisms that are onto. that have the kernel, the ideal that we're looking at.